think about what you're doing before you do it. Think about what you're doing before you do it. If you have that mentality, instead of, and you hear me say, don't be a robot, or don't, I've said in the past, monkey see, monkey do. A lot of people will see a problem, and because we've done something similar to that, they're going to use the same route that they've already used, and they may or may not get to the right conclusion, but regardless, if they're not paying attention to what they're doing, or not thinking about their steps and thinking about what the next step is going to provide them, they might be wasting time, okay? So as we do a couple of these examples, my hope is to kind of demonstrate that aspect of thinking while you're doing something, okay? Now, in order to do this, this contrasts to algebra, and this is where this class is, I think, drastically different than what you learned last year in algebra, and basically drastically different than how you've been trained all your life in mathematics. You have always been provided with an equation or an expression, and you were told, solve this, do this, okay? Do this route, do this set of steps. This is just saying solve for x and y. They don't give you any equations. Geometry is governed by these theorems, these postulates and definitions that develop relationships for us, right? We have to be able to understand what those things are, what those postulates say, what those theorems say, what those definitions say, so that we can create the equations ourselves. And once we create the equation, then we have the tools from Algebra 1 to start actually solving the equations. All right? So, we need to generate some relationships here. We need to come up with a link between sets of angles here. Okay, so what would you guys tell me is true maybe about that angle there and that angle there? Okay, so they're supplementary, right? Add up to 180. Perfectly fine. So I'm going to say 5y plus 3x equals 180. Okay. Now, last year, and you can do this next step. I want to talk through it, but I'm not going to do it because I don't think it's useful here. But last year, if you got an equation like that, if you remember, that's called standard form. Okay. The way it was introduced in algebra when you started doing this stuff is that they called this, like anything in the form of ax plus by equals c, is called standard form. Okay? Now, we would have to move the 3x and the 5y around to actually mimic that. And there were rules about a having to be positive and that kind of thing, but I don't care about that. All I care about is that we've got x's and y's on the left-hand side. Okay? And our constants on the other side. What you can do is maybe solve for y here. You guys remember doing that kind of thing? Solving, they're called literal equations. And basically you subtract 3x from both sides, and then you divide both sides by 5. Now think about that. If you were to go ahead and do that, you would end up with y equals negative 3/5 x plus then 36. Okay? I don't like that 3/5 x. I don't like having that fraction. Okay? And it's avoidable. So if I know it's avoidable, I'm not going to do that route. Okay? But here's the thing. We can solve that equation for x, or we can solve it for y, whichever we want. But that's going to give us a formula for x or a formula for y. Does that make sense? It's not going to give you a numerical value for x or a numerical value for y. And that's what we really want here. Okay? So you guys remember what you're supposed to do if you have an equation that has two variables? You need one more thing in order to solve that. Does anybody know? And it's the reason they give you that x plus y plus 8 up there. If I have an equation with two variables, in order to solve that, I need an equation that has the exact same two variables. I need a new equation that has the exact same two variables. Would you make an argument that that and that are also a linear pair? That make sense, everybody? So could I write the equation that, now I'm going to merge these again, I'm going to combine like terms right away. So that'd be 4x plus y plus 8 equals 180. Be a second equation. Okay? Now, that being said, and I don't know the best approach to kind of discuss this or talk about this, so might as well just do it right now. There's more relationships here. What do you know about those two things? They are also equal because of vertical angles. So that's our third relationship. We've got now a third equation. So I'm going to write I'll just write it here. 5y equals x plus y plus 8, right? Okay. Now, neither of those equations that I wrote on the right-hand side are in what we call standard form. Okay. So maybe we want to kind of jockey around the variables in terms to put it in a standard form. But here's the thing. And if I'm going to solve an equation that has two variables, I need another equation that has the exact same two variables. If you remember the vocabulary last year, that's called a system of equations. You remember hearing that phrase? System of equations. You guys remember taking this equation here and graphing it, and then taking one of these equations and graphing it, and then where they crossed was the solution? You guys remember doing that? Okay, I see some heads bobbing up and down. Because these three equations are true, because they're all valid, it doesn't matter which two I pick. It doesn't matter which two I pick, but I got to use two of them together. Okay? Early on, I'm just going to pick the first two. Okay? To hopefully maybe prove a point and talk about kind of the time that takes to prove or to find the solution using those two. There are two techniques. There's a substitution technique and there's an elimination technique. You remember those phrases? Okay? If we want to use substitution, okay, I'm using these first two equations, equation 1, equation 2, equation 3. I'm going to use 1 and 2. If I want to use substitution, what it means is I've got to look at my variable terms and see which one would be easiest to replace. So I'm going to look at that red equation. Does it make sense that it would be really easy to rewrite this red equation as y equals, would be negative 4x plus 172. Does that make sense to everybody? Now, the reason I would do that, if you remember last year when you were introduced to substitution, all the questions that they provided you with had a variable term that had a coefficient of 1. I recognize that y there in that first version of my equation had a coefficient of 1. So it was easy for me to solve for that variable. Now, why would I do that? Because now if I know what y is, that is the same y that is right there. And that's saying I've got 5 of them, right? So what I can do, this is the substitution technique, is that I can replace that y with negative 4x plus 172. Then I've got my plus 3x equals 180. That's the substitution that we've talked about, right? Okay. So now if I take 5 times negative 4, I get negative 20. 172 times 5 gives me 860. Plus then 3x equals 180. Now look at what that did. We started off with two equations. They had two variables, right? Had x's and y's. Now, how many variables does my equation have? How many variables does that equation have? Just one, right? So we have an equation with only one variable, and that's what we're looking for. We're trying to get what we started with, two variables, dwindled down to an equation that is still true that has only one variable. So now if I combine like terms, I get negative 17x. Okay. I'm going to move this 860 over. Okay. So what's 180 minus 860? Say again? Okay. So then I'm going to divide both sides by negative 17, right? Okay. So this is actually negative 680. So negative 17x equals negative 680. If I divide by negative 17, it gives me 40. So x is 40. Does that make sense? So now if x is 40, I should be able to find y. Now all of our equations up there, the blue one and the red one and even the purple one all the way on the right, incorporate x and y, right? As long as you know what x is, plug it into one of those, and it should generate and spit back y. It makes most sense, I think, to plug in here, because that's already got y isolated, right? So all I've got to do is take negative 4 times 40 plus 172. What's negative 160 plus 172? That gives me 12, right? My y value here would be 12. Okay. Now, if you wanted to check yourself, which I think we did a lot of work there, right? So it would be, I always kind of base my decisions on whether I should check my work or not based on how long it took me to do the work. If it takes me a substantial amount of time to do the work, I'm going to check myself before I go on to the next thing. So if I plug in x to be 40, this here would be 120 degrees, right? Okay. If y is 12, 5 times 12 is 60 degrees. What's the relationship then between those two things? Are they indeed supplementary? So that checks out. And I'm going to go a little bit further. Okay? We had x, which was 40, plus y, which was 12, plus this 8. Does that also give me 60 degrees? Does that show me that that top angle 120 and that angle 60 are supplementary? And does it show me that the left and right ones were vertical, 60 and 60? Does that make sense? Okay. Now, that being said, and this is going to happen all year long, guys, because I want you to be able to recognize that there's multiple ways of doing something. And if there's multiple ways of doing something, there's always a fastest way, right? Okay. If we look at these two things, let's just use the same two equations. We had 5y plus 3x equals 180. Okay. Now this one was 4x plus y plus 8 equals 180, right? Can I rewrite that as 4x plus y equals 172? 4x plus y equals 172. 4x plus y equals 172. You guys remember doing something like this last year? Where I lined my y's up, lined my x's up, and I started adding straight down my coefficients. Now if I did that, I get 6y plus 7x equals whatever, and nothing canceled out, right? You guys remember wanting something to cancel out? What's the best thing here to cancel? The x's or the y's? If I wanted to cancel my x's, what would I have to turn them both into? One would have to be a positive number, one would have to be negative. But it'd be 12, wouldn't it? It'd be the, you multiply those together, it'd be the product of those two things. So I'd have to change the top equation and multiply the top equation by 4 and the bottom one by maybe negative 3. Okay, that'll work. But doesn't it make more sense, instead of canceling the x's, to cancel the y's? How many of those equations do I have to multiply? Just the bottom one, right? Just multiply the bottom one by negative 5. And what that's going to give us, okay, if we start multiplying that, it would be negative 5 y, minus 20x equals, so 172 times the 5 was the 860. And that top equation is still the same, 5y plus 3x equals 180. Now, what I want you guys to understand is that people think these are completely different procedures. Completely different procedures. But if you think about it, Didn't we end up multiplying this one over here by 5? This negative 4x plus 172 by 5? We got the 860. We got negative 20. Okay? Same thing's happening here. Okay? So they're really not different algebraic properties at play here. It's just a different way of aligning things. Add straight down, those are going to go to 0. You're getting negative 17x. And again, then you're going to get negative 680. That's the same equation as that right there. So again, x is going to be 40. Does that make sense? Okay. I think that's time consuming. I think both of those are time consuming. And here's the thing. Then we have that third equation. That third equation was kind of floating out here that we haven't used yet. Okay. I'm going to look at my three equations, and I think the 5y plus 3x equals 180, and this one of 5y equals x plus y equals 8 might maybe work well together. Okay? If I go 5, it's actually going to be what, 4y? So 4y, move that y over, minus x equals 8. Maybe I use those two together, that one there and that one there, okay? Because now instead of using 180 and multiplying 180 like I did in that red one, now I'm multiplying 8 by something. Does that make sense? Okay? It's just going to allow me to use smaller numbers. So those are kind of things to think ahead and realize, do I want to multiply large numbers or would I rather work with smaller numbers? Okay? You can do the same thing with these two if you want to use those two. Okay? When I use substitution, this is a topic we're going to kind of stop with this question here in a moment. But when I use substitution, it doesn't have to be like x, solve for x, and plug x in only. Okay? If I wanted to use substitution, could I, right here where this is 5y, okay, can I substitute 5y with that thing right there? Does that make sense, everybody? Okay. Do you see right here where you got a y plus 8? Do you have a y plus 8 right here? If you wanted to come over here and replace that y plus 8 with 5y minus x, you could do that. Okay? As long as you have somewhere in your equation that you're going to be doing the substituting into, you have a expression for what you want to substitute, you can do that. Okay? I think last year you probably taught only substitute with 1y, only substitute with 1x. Okay? It doesn't have to be that way. All right? Does it make sense on how to do that? Now, that question, and like I said, I don't know, we compared or equation 1 and 2 together and done all the work, and then paired 2 and 3 together and done all the work, and then paired 1 and 3 together and get done all the work. So you compare any two of those equations and do the work and get the answer. Okay? I don't know which one's going to be quicker. Okay, I do like the ability to work with 3 because that's smaller numbers, but there are some that will pop up. There are some questions that will pop up that it will ultimately be so much quicker if we think about what we're doing. Okay? Now, what I want to do real quick before we go to the next one is actually give you a tool here to help with this process if you're able to use this tool. Okay? Now, what I mean by if you're able to use this tool, when you are on the end of course exam, you have Desmos at your disposal, but it's not the graphical version of Desmos. Okay? So this is something maybe you can work on in your homework. I'll let you use this on tests and quizzes. But if you focus on just using this to get answers and you don't understand how to do that algebra, when you get to the end of course exam and they take this away from you, you're not going to know how to work with systems equations. Does that make sense? So I want to show you guys tools to use to help you, but I don't want you to commit to and say, oh, that's the easiest way to get the answer, and that's what I'm going to use every single time. Okay? I want it to be something that you, I don't want the best word here for it, you use it responsibly. Okay? So what I'm going to do is I'm going to type in these equations, 5y plus 3x equals 180. Okay, and you saw it was graphing, and I got to zoom out a little bit because that 180. But it gives me that line right there. You guys did that last year. You let x be 0 and solve for y. And then you let y be 0 and you solve for x, and that gave you your x and y intercepts, right? Okay, and you graph that line. Now we had another one. We had another equation that was 4x plus y plus 8. 4x plus y plus 8 equals 180. And we got that line, right? And last year, so the first thing that we did with this is that we graphed those, and we tried to see where they met. They met at 40, 12. Are those the x and y values that we found by hand? Does that make sense? Now, this is what kind of stinks, is that was really quick. That was a really fast process to find that answer, right? And you're going to be tempted in a homework. Oh, he just said I could go Desmos, type these equations in, and I'm going to be successful. And that's true. And even if you did that, you've shown me you know the geometry, because the geometry was setting up the equations, making the equations. But if you neglect to practice the algebra, the end of course exam is going to be an unfriendly experience for you. Okay, so use this as a tool, not as a crutch. Now, here's the reason why it doesn't matter which one of these equations we use, or any two of these equations that we use. Do all three of those lines go through the same point? Okay, they all go through that 40, 12. Okay, we call those lines concurrent. Okay, the word concur means to agree, right? Okay, I might hear old people say that. You say something and say, I concur, right? It means they agree. So these lines all agree that they have the same, basically their intersection is that agreement. Okay, they all have the same point, 40, 12. So that's why we can choose maybe those two, or just those two, or just those two. We get the same answer. I know that's a kind of a long-winded explanation for that problem, but does it make sense? We feel a little bit more comfortable with being able to do that? I want you guys to look at this one here. This is one of our homework questions tonight. Is that the same setup as before? Same exact setup as what we just did, right? Okay, so let's take two relationships. What are you going to tell me about that one and that one? Supplementary, right? So I'm going to say 2x plus y plus x equals 180. There's my first equation. What are you going to tell me about that pink one and that pink one? Supplementary, right? Okay. Y plus x plus y minus x equals 180. And then what are you going to tell me about that one there and that one there? They're vertical, right? We say 2x equals y minus x. Okay? So, going off of what we just talked about, it doesn't matter which two you choose, right? If I were just to randomly choose two of those equations and not really think about what they're generating, I might waste quite a bit of time. For instance, if I chose equation 1 and equation 3, I'm probably going to waste some time. However, if I look at that red one and choose to take that red one with any other one up there, that red one, what happens right here with these two things? Positive x and negative x, they cancel each other out, don't they? And they give us 2y equals 180. And this is a special set of a system, or special system of equations, because you really don't have two variables in that red equation. Your x variable has a coefficient of 0 ultimately. So what's y going to be here? Y equals 90, right? Can I then take that 90 and plug it in there, or maybe plug it in there, and and solve for x. Does that make sense, everybody? I think x would be 30 in this case, right? I think that's thinking, that's looking and analyzing each one of those equations, which it might take me 10 seconds to analyze each one of those equations, but that 30 seconds that I waste analyzing those equations is maybe it pays off in the long run because maybe I saved myself 3 or 4 minutes in the algebra. Does that make sense? Okay. You've heard the phrase hindsight's 20/20, right? Okay. You know, if I do something and I mess it up, and then I look back and reflect on it, and I can realize what I did, and how I messed things up to fix it the next time, right? Well, let's clear our vision up a little bit before we even go through any processes. Think about what you were doing, okay? And that's going to be something that you hear me talk about all the time throughout the rest of the year. Always be thinking, because there might be 10, 15 different ways to do a problem. But you don't want to be that person that accidentally chooses the long route on every single problem, right? Because then you're going to be at the end of the year on a test and you're going to run out of time. Okay? You're going to be on the ACT, 60 questions, 60 minutes. And you're not going to get to answer them all or read them all. Okay? So that's kind of what one of my goals for us is to do in mathematics. And it's a different way of approaching math. And maybe you haven't done that in the past where you're thinking ahead. Okay? I want us to be able to do that. Does that help talking about those two questions? You just want to do another one, or we feel comfortable? We can do any of these. I can't hear you guys. Do another one? Okay. Let me just give you want to do it, and then we'll come back and talk about it? Or you want to do it together, whole thing? Do it and come back? Okay. So I'll give you a couple minutes here. Give that one a shot. If we look at this one, it's the same relationships that exist, right? We should be able to see, hopefully, that we've got the opportunity to look at these two as a linear pair, correct? And that's my equation 1 here is looking at those two as a linear pair, okay? My equation 2 is looking at that one and that one as a linear pair, and that's getting me that equation 2. Okay? And then my equation number 3 is looking at those two being vertical, and I get y equals 4x, right? Okay? Now, as I analyze those equations, I think maybe it makes sense to kind of quickly combine like terms. Okay, so that's how I've got the 5x plus y equals 144, x plus 2y equals 144, and y obviously equals 4x. Okay? Now, here's the thing. This is how I use Desmos. This is how I use GeoGebra. This is how I use any online calculator. Because you can Google any type of online calculator you want, and there's somebody that's already made something that's going to allow you to get some answers. Okay? This is how I would use it. I would graph those things. And I just graph the kind of those most basic versions of my equations. And I look at them, and I know that the answer now should be 16, 64. I know the answer before you do any algebra. Does that make sense? And then that can, as you start working through the problem, that can maybe give you reassurance or some confidence that you're doing things correctly. Okay? So I know the answer should be 16 and 64. So let's see if we can do this. Okay? Now, as I analyze those red equations, or even looking at the blue ones, which one is the most simplistic? Y equals 4x, right? That's the easiest one up there. So I probably want to use that. Now here's me foreshadowing a little bit. Okay? Do I want to have to double that y, or do I want to have to leave that y alone as just one y? I would leave it as one y, right? That's a direct substitution. Okay? And now I can have, so I'm going to use that top equation and the bottom one. I'm going to substitute that in right there, so I get 5x plus now 4x equals 144, right? 9x equals 144. How many times does 9 go into 14? Once, right? And it leaves me a 5. How many times does 9 go into 54? 6 times. If that's the x that we said that we were going to get when we looked at our picture, we looked at the graph, okay? And now what's awesome about using that green one, now that you know what x is, can you multiply it by 4 and get what your y is? Okay? Now, those are the two that we use. If you're a person that uses just the red ones up there, 5x plus y equals 144, and x plus 2y equals 144, you're still going to get x to be 16 and y to be 64. It's just that your math is going to look a little bit different. Okay? But as long as you have that support of your work, it doesn't matter the route you take unless you're trying to be efficient. Okay? And then I think it really matters. And that's what math is all about. I told the last class. Think about this. Would you guys want to write would you ever want to write that out? That's repetitive addition, right? So we have in mathematics, we say, well, repetitive addition, instead of writing out 2 plus 2 plus 2 plus 2 all those times, isn't that say the same thing? Would you ever want to write out something like that? So repetitive multiplication is exponents, right? Does that make sense? Okay? So our mathematics, our system, allows us to do those procedures and things like that very quickly, okay, to be efficient. Our theorems, our postulates, and our definitions that we talk about in this class, the reason we need to learn those and understand what is stated inside them is so that we can come across problems like these, okay, problems like these here, and be able to address them efficiently, okay? Be able to know the relationships that allow us to create equations and then analyze those equations algebraically to come up with our solutions, all right? I sent you guys an email towards the middle of last period that's got 2 documents in it, okay? I don't know why over the years I've separated them, but it's just one worksheet. But then you got to open 2 documents to get the whole worksheet. That is your homework this evening. One of the questions is this one here, okay, that we did together. That is going to be due tomorrow at the beginning of class. Okay? Tomorrow at the beginning of class, that worksheet will be due. Should get you to practice some more of the concepts that we talked about today.